Hello class, how are you and how is our previous lesson so far? Oh, we are still discussing on atoms, or what to call atomic theory. So today we are having chemistry, Danton's atomic theory under the particular nature of matter. Remember, we are still discussing everything is centralized on that matter. Anything that has mass and occupies space. Today, let's just look into the Danton's atomic theory as another subheading under that particular nature of matter. Now, in the year 1808, when an England, a philosophist and also a great scientist known as John Danton, put forward theory. But before I proceed to tell you all these theories, I must tell you the difference between law and theory. Now, when you come to chemistry, when you go to number one method of chemical analysis, we have what we call theory. We have what we call law. Law is the last thing that you can have. After your observation, the first one should be research. After your research, your observation, your hypothesis, your other sector, thing that you can do. After that, you are going to put forward to theory. A theory means something that has not been fully accepted by everybody. All the scientists have not accepted it, or they accepted it partially, waiting for further research. That is the meaning of theory. They say the statement is theory. It means that there are people that are still researching on that your statement called theory. Now we have what we call law. Law is after the research has been conducted by many scientists. Now all of them will now conclude that yes, what this person put forward as a theory is really the truth. They have gone research over and over again and found out that it is truth. That is the meaning of theory and law. Law cannot be changed. Just like when you come to chemistry, we have what we call Charles law, we have what we call Boyle's law, we have what we call general law, diffusion law. So all this becomes law, cannot be changed. But theory can be changed. So during the research of atom in the year 1808 by an England scientist known as John Danton, this man put forward something about atom, atomic theory, and that is what we call atomic theory. Atom, remember, we say that atom can be defined as a smallest particle of an element which can take part in chemical reaction. Now with this, John Danton of England put forward some theory. What are these theories? He said that when you come to this atom that we define so far, he said that all elements are made up of small indivisible particle called atom. All elements, like we have element, the hydrogen, the helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all of them, both magnesium and what all the rest. We have the magnesium, we have the aluminium. Now all those elements now, they say that all those elements are made up of small indivisible particle. Indivisible means something that you cannot divide further. It cannot be separated. That is what John Danton stated. But the fact is this: during Rutherford research, another great scientist, the man came up and said, how can this man say that all elements are made up of indivisible particles called atom? It's not like that. Both the Rutherford and John Danton, they started arguing it. As they keep on arguing, they found out that inside an atom, there is other things that you can see there. What are those things that you can see? One, you can see proton, you can see neutron, you can also see electron. These are the things. But the man, John Danton said that element is made up of small indivisible particle called atom. Now when you have an element, inside an element there is an atom. But John Danton is saying that there is nothing that is inside this atom again. But Rutherford said no. He said no. But because when you come to this atom now, which is this one that is inside element, you are going to see this and this. This is what we call proton, while this is what we call neutron. And inside this orbit, you have what we call electron. So Rutherford now say no. that this number one theory of John Danton will not be accepted. Why? Because inside atom there are other elements. That's the reason why this law, this theory was or is proved wrong till today. So we are no longer in chemistry. We no longer use this particular theory of John Danton because of what Rutherford said. So number two, he said atom cannot be created nor or destroyed. Atom cannot be created or destroyed. Now, what is this John Danton is trying to say here? John Danton is trying to tell us that you can never destroy atom, no matter how anything you do. But the fact is that Rutherford continued doing research. That's the reason why I love scientists, and that is why I want you people to be a great scientist. Because scientists don't accept what somebody has said so far, or what your fellow scientist has said. When somebody says, make any statement, you have to think about that statement and go further research before you can say something. Now look at what Rutherford say here. Rutherford say, John Danton, you are telling us that atom cannot be created or destroyed. But when you go to Uranus, you have what you call uranium. That uranium, during the construction of bombardment, or what you call nuclear fission, we have what we call nuclear fission. Nuclear fission means the splitting of an element into different parts. Now when you go, you will now find out that we have what we call uranium. And this uranium, we have capital U, which is of 238. And we have what we call 92 here. That is the atomic number and their mass number. Now, this uranium split into two. This uranium is an element, and this element now has the atom inside. Now, this uranium, during what we call nuclear fission, the bombardment of this uranium, it separates to have what we call thorium, which is another element again. So, the bombardment of this particular element to split into two, to have the uranium and have thorium and helium. You have the two things. Helium. Make this number two theory of Danton wrong. He proved it wrong. We watch it very well. He said this atom of an element, an atom cannot be created or destroyed. Yes, that is what the man said. But Rutherford said, John Danton, why do you say like that? Now, when you go to the bombardment of what we call the nuclear fission of this uranium, you will now see two things there. What are the two things? The thorium and what? Helium. These are the two things that can split if you bombard this. But the man is saying you cannot destroy them. So that is what makes this number two theory wrong of John Danton. So John Danton was even worried. How can this man come up and begin to disapprove all my theory like this? So John Danton have to go for more research in finding out the correct statement. Now, number three, atom of the same element are exactly alike. That is another theory of John Danton. Rutherford say, come, enough is enough of all this fake theory that you are giving to us. Now look at what you are going to do. Now if you say that atom of the same element are exactly alike, why do we have what we call isotope? We have what we call isotope. And what is this isotope? An isotope is an existence or a phenomenon which is used to describe an existence of an element with the same atomic number but different mass number. So in that place, you are going to have chlorine. Chlorine is an element. And this chlorine, it appeared two times. We have chlorine of 37 and 17. We have chlorine of 35 and 17. So this becomes what we call an isotope of what? Chlorine. That is it. Now, but the man is saying in number three that atoms of the same element are exactly alike, which is wrong. So Rutherford now proved John Danton wrong of both number one, number two, and number three theory. Because if you talk about this number three, that atoms of the same element are exactly alike, they are not alike. Because this one has, we also still have carbon. We have carbon of 13 and 6. We have carbon of 12 and what? 6. This is an isotope. So they are not exactly alike. They are different. There are differences there. Now we have number 4. Atom of different elements can combine in simple whole number or whole number ratio? Yes, Rutherford say yes, it is true. Because when you come, you can do the combination of this atom. We have sodium plus chlorine to have what we call sodium chloride. So Rutherford accepted number 4 theory of John Dalton. Also, number 5, all chemical changes result from combination or separation of atom. That one is also accepted by Rutherford. So after the theory of John Dalton and what Rutherford has put forward so far, all the scientists, both the Rutherford, both John Dalton, they come together to form what we call modern atomic theory. And this is the modern atomic theory that we are using today. And what is this modern atomic theory? Number 1, atoms of the same element are not alike, which is true. When you talk about isotope, just as we stated before, they are not alike. Isotope of chlorine, 37 of mass number and 17 of atomic number. We also still have another one, 37 of atomic number, 35 of atomic number and 17, atomic mass and atomic number of 17. This make it what we call isotope. So with this isotope, it's stated number 1. This number 1, atom of the same element are not alike. With this, they are not alike. Also, we have oxygen. We have oxygen of 16 mass number and 8 atomic number. We also still have another one of 17 mass number and 8 atomic number. So if you find out that you see that these two oxygen, they are not alike, that is number 1 theory. Now we have number 2. An element may have atom with different mass. An element may have atom with different mass, which is true. When you come to this place, oxygen is an element, and this element which you are seeing here, you can see different masses. We have oxygen, but the mass of this one is 16, while the mass of this one is 17. That is why they said an element may have atom with different masses, their mass number. That is number 2. So number 2, modern theory agree with what they have put forward as a modern atomic theory. Number 3, atoms of different can combine together. Atom of different can combine together. The atom of sodium can combine with the atom of chlorine. The atom of oxygen can combine with atom of calcium. That is this number 3. Number 3 is telling us that the atom of different elements can combine together, which is true. Now we have number 4. Molecules may further broken. Molecules may further broken. Just like when we discuss about molecule. What is this molecule? We say that molecule is the smallest particle of an element which is capable of being independent but still retain the chemical properties of that particular element. That is what we define when we are discussing about the first particulate nature of matter. We discuss about atom, we discuss about molecule, we also discuss about ions. So with that, if I have this, we have oxygen here, and how many molecules of oxygen is here? You find out that it is 2. Remember, I stated this when I was explaining about molecule. This become what we call the molecule of oxygen. We also have another one here, molecules of nitrogen. We also still have molecules of chlorine. This become molecule. But the fact is that this oxygen can split into 2. To have, once it is split into 2, you are going to see oxygen and oxygen. So it is because of oxygen combined with oxygen to give me this oxygen molecule. So that is why this number 4 says molecules are the same. Molecules may further broken. Molecules may further broke into 2. So the molecule of oxygen has broke into 2 to have oxygen atom. 2 oxygen atom. Then this oxygen atom and this oxygen atom can combine together to give me what we call oxygen molecule. That is why we agree with this number 4. Then we have another one. Molecules are the same, are the smallest particle of a compound. Yes, it's the smallest particle of the compound. We have number 4. Molecules may have structural composition. That is, what are they made up of? What they are made up of. Like when you come to chlorine, or when you come to any compound like uranium as an element, uranium composes 1, thorium and helium. These are the 2 things that it composes inside. That is why we accepted this number 6. Number 6, molecule may have structural composition. Then the final one says matter are made up of small particles which are positively charged or negatively charged. Then just as we discussed about ion. In that ion, we say that ion are atom or group of atom which has positive or negatively what? Charge, or which possess electrical charge. So when you come to an atom of an element, it possesses a charge. This is a matter. Inside this matter, we have what we call the proton, we have what we call the neutron. Here become what we call the proton, here become what we call the neutron. Here, inside here become what we call the nucleus of the atom, while here become what we call the electrons, the electron of the atom. The proton is positively charged, while the neutron is negatively what? Charged. That is this law number 7. Matters are made up of small particles which are positive or negatively charged, and that is truth. So because of that, we quickly go into what we call the valency. What is the meaning of valency? Valency simply means the combining power. Valency, the combining power of an element. The combining power of an element, an ability of an element to combine with another one. That is what we call valency. Now quickly, let me give you the table of elements with their valencies and their oxidation number. Their valencies and oxidation number. As I said before, valency is the combining power of an element. Now we have the following elements. We have number 1, hydrogen. We have hydrogen. We have valency. We have the valency. We have what we call their oxidation number. Oxidation number. Okay. Now I have hydrogen. Hydrogen has a valency of 1 and the oxidation number of +1. I have calcium. The valency is 2. The oxidation number is +2. I have magnesium. The valency is 2. The oxidation number is +2. I have chlorine. The valency is 1. The oxidation number is -1. I have oxygen. The valency is 2. The oxidation number is -2. I have nitrogen. The valency is 3 or 5, while the oxidation number is +3 or +5. I have triosonitrates. Triosonitrates. Triosonitrates, NeO3. NeO3, triosonitrates. The valency is 1, while the oxidation number is -1. I have tetraoxosulfate 6. Tetraoxosulfates 6. SO4. The valency is 2. The oxidation number is ±2. I also have triosocarbonate by oxocarbonate 5. Triosocarbonate 4. I have triosocarbonate 4, CO3. The valency is 2, while the oxidation number is -2. We have also iron 2. The valency is 2, while the oxidation number is +2. We have iron 3. The valency is 3, while the oxidation number is +3. We also have copper 1. The valency is 1, while the oxidation number is +1. We also have copper 2. The valency is 2, while the oxidation number is +2. Let me just stop for here. When you get to textbook, you see many of them. So I just want to use this one and give you some examples. Now, as we have this, when we talk about this, their valency means the group which they belong to. Anyone that belongs to group 1 element, when you come to a periodic table, it has what we call 1 valency, and that 1 valency is the same thing as 1 oxidation. Now, if the one that belong to group 2, they have a group that is 2 valency or 2 oxidation number. Likewise, group 3 and group 4 and 5. So when you come to hydrogen, you see 1. When you go to calcium, you see 2. But we are discussing about what we call valency before we now enter into what we call oxidation. Now, what is this valency? As I say it is the combining power of an element, an ability of an element to combine with another element and get successful formula. Now, with this, which I have written on the board, I'm going to give you some example. And what are the example? If I want to combine something like magnesium and chlorine, watch it very well. I will write Mg, which is the symbol of magnesium. Mg, which is the symbol of magnesium. Now, the next thing is what is the symbol of this chlorine that I want to combine it with? You have to understand with me that the symbol of chlorine is Cl. Now, go to this their valency, which is the combining power. What is the valency of magnesium? 2. Correct. So these 2 you are seeing here, you are going to put it here under. You have 2 of magnesium. Now, what is the valency of chlorine? The valency of chlorine is what? 1. You are going to put 1 here. Now, because we are talking about the combining power of an element, which is what we call valency, let's do this combining power. There will be an exchange of valency. Magnesium 0.1, chlorine 0.2. Now, because of that, I'm going to have magnesium 1, chlorine 2. That is what you are going to see. And 1 times this magnesium is the same thing as magnesium. Therefore, I'm going to have MgCl2. This become the answer, magnesium chloride. So that is what we call the combining power of an element. Now, anything that makes you to write magnesium chloride without these two, that is, you are now introducing another chemical formula which is not in the chemistry textbook. So that is to say, you are now trying to write your own textbook, and you must give reason why you write magnesium chloride without these two. Now the chlorine now has picking the 2 of magnesium. Why that of 1 is being what? Lost, because 1 times Mg is the same thing as Mg when you come to your law of indices in mathematics. So it's the same thing. Now we can also have magnesium and oxygen. Let me give you another example. Magnesium and oxygen. I can have magnesium, look at it here, magnesium. You also have oxygen. Now you are going to do the combining power. What is the formula of, what is the valency of magnesium? 2. And what of the valency of oxygen? 2. The same thing. We are going to have 2 here. Now cross this together, cross this together. So I'm going to have magnesium 2 and oxygen 2. Now since 2 of them, magnesium will have 2, oxygen they have 2. What we are going to do is this. Cancel these 2, cancel these 2. So you are going to have magnesium oxide. This becomes the answer, because you cannot put the 2 subscripts under. It cannot make any sense. It's just that when you put the same 2, is as good as putting 1 1, or the same thing like putting 1, which does not make any sense. So nail off the 2 sides, that 2 of the subscript, so that make the equation to what? Be balanced. This becomes what we call magnesium chloride. But if this subscript and this are not the same thing, please leave it like that. Just do your normal exchange. Now let me have another one like aluminium. Aluminium is not here. Okay, we can put aluminium here. Aluminium. Now we have aluminium has a valency of 3 and oxidation number of +3. Let's check aluminium now. Now I'm going to have aluminium and chlorine. Aluminium and chlorine. We have aluminium and the thing is 3. Why chlorine become what? 1. Do the exchange. You are going to see something of this nature, exchange of the valency. So aluminium is going to become what? 1. While chlorine is going to be what? 3. Then 1 times Al is the same thing as Al, and this becomes aluminium chloride. So the chlorine carries the 3. But with this, let's quickly go into the higher one, because these are the simpler ones. Let's check triazonitrates. Triazonitrates. In triazonitrates, we have number 1, triazocarbonate 4. If I want to do the combination between aluminium and triazocarbonate 4, aluminium, let's see their valency. Aluminium and triazocarbonate what? 4. Let's see this one. What is the valency of aluminium? 3. Now what is the valency of triazocarbonate? 2. So I'm going to have 2 here. Now by the exchange, you see something of this nature. Now aluminium is going to be aluminium 2 white triazocarbonate. Look at this 3 that is here, so that you will not mistake 2 of them. If you mistake this 3 and this 3, there will be a problem. There are some people, they will write it 33, but it's not going to be 33. Watch what I'm going to do now. Now we are going to have CO3, which is this triazocarbonate here. Now this 3 is affecting all the whole of both the carbon and oxygen and this 3. So because of that, you are going to close this bracket, close this one inside house, and put your 3 here. And this becomes aluminium triazocarbonate 4. That is what you are going to have there. So that is how it's supposed to be. Now you can have, let me just do another example of this one. You can have calcium and tetraoxosulfate 6. Calcium and tetraoxosulfate 6. Calcium has a valency of 2. Tetraoxosulfate 6 has the valency of how many? 2. We wash our table very well. Therefore, I'm going to have calcium 2 tetraoxosulfate 6 all in brackets 2. So cancel this, cancel this. The answer is going to become calcium tetraoxosulfate 6. That is what you are going to have. Make sure you nail off the 2 subscript. So we have iron 2 chloride, iron 3 chloride, iron 2 chloride. We have also copper 1 and copper 2 chloride. Copper 1, copper 2, aluminium. So you can exchange any of them like that. So that by making sure that you cross their valencies, so that the valency of one will become to the other, while the next should be for that of either copper 1 or any element that you are using for the valency or for the combination. Now quickly let us look into what we call oxidation number, and how do we calculate the oxidation number.